All right. Good afternoon, everybody. Thank you guys for joining us here today. We're excited to have Shon Isenhour with us from Eruditio. He's going to be talking to us about 5 things to be thankful for that help improve site reliability. So kind of a play on the upcoming Thanksgiving holiday, but he's got some really great content, and so we'll have some fun with it today. Just some housekeeping before I turn things over to Shon. We are recording this, so if you have to hop off or if you've got folks that wanted to join in and weren't able to, we'll make this available on our website, as we always do. And we also welcome questions. So there is a little questions box, and I especially want to point that out because if you all have ever heard Shon speak before, you know that he likes to make things as interactive as possible. So not always the easiest thing to do when we're doing a webinar, but he does have a couple points where he's going to look for some feedback. So we'll look for you guys to use that questions box, not only to ask questions, but to kind of play along with part of the presentation as well. And of course, for those questions, I'll be keeping an eye on those, and we'll get those tossed over to Shon if it makes sense during the presentation for him to clarify something, or of course, typical Q&A at the end. And I do always like to point out that we are doing this live, so if we run into any audio issues, if any of you were on our last one, you know, unfortunately that did happen, or connection issues, things like that, we'll try and get things resolved as quickly as we can. But we do like having that live atmosphere, so we kind of take that little small risk of those technical issues popping up. So with that, though, I am going to let Shon take over, and I'm going to pass the screen to you, Shon, and let you roll with it.
All right. Well, good morning, everyone, or good afternoon, depending on where you are. So today we're going to talk a little bit about things that you can be thankful for. And I'll tell you a little more about where this came from and why Maureen and I decided to put this out as we get a little deeper into it. But as Maureen said, we are going to do a little bit of question and answer. I'm going to pass she's going to pass some information over to me. I hope everyone will be engaged with that as we move forward. Just a brief introduction. My name is Shon Isenhour. I'm one of the partners with Eruditio. I'm actually coming to you today from the USS Shoretown, sitting in the middle of Charleston Harbor. So if you hear anything weird in the background, very well could be anything from a helicopter to needle guns from the repainting of the ship. So we'll try to keep that to a minimum, but just always like to let people know that very well could happen. A little bit about me outside of work. This is a lot of what I'm thankful for. You see my daughter here on the screen enjoying some of the Halloween festivities just recently. You also can see helicopters and airplanes, 2 of the things that I enjoy spending time with. Those of you that have sat through my training sessions know that we use those examples quite a bit during the training. One thing that I do want to point out, the reliabilitynow.com blog down in the corner there. Great place if your facility is looking to make reliability more a part of your day in and day out activities. You can jump onto the Reliability Now blog. You can grab a quick little blog and share that with folks, a lot like what we do with safety, kind of as a toolbox topic or a daily reliability topic to keep it in the forefront. I think that's one of the biggest things that we can do. We know safety has improved over the last few years tremendously, even over the last 20, almost exponentially. And I believe personally one of the reasons that has happened is because it is constantly in the forefront. It's constantly getting mentioned. And so I always kind of challenge people, are you doing the same thing with maintenance improvement, reliability, and asset management? Are you putting that stuff out there on the day in and day out? A couple of the other pictures you see there, helicopters and airplanes. Talk just briefly about it. I've done quite a bit of racing in something. It's what we call a junkyard series. And in that series, you basically have to take a $500 car. You got to race it around the track for anywhere from 8 to 24 hours. And you've got to do that with pretty much no reliability issues, because anything more than one extra pit stop, you can pretty much guarantee you won't be on the podium. So with that said, reliability becomes a really big part of that. If you think about that car, when we bought it, it was sitting in a person's backyard with grass around it. And we had to take that vehicle then and get it up to a level of performance that we could then run a 10-hour race or a 12-hour race, or even in some cases 24 hours. I imagine that's not that different than some of your equipment that's in your facilities. You know, it may have been purchased to do a little bit of work here or a trial run there, or it may have been purchased to be run at one speed, and now you're running it at twice the speed. You may have bought it for $500, just like that vehicle, or at least it seems like it. So you've got to deal with the junk that came out of somebody else's backyard. But anyway, so reliability is a big part of not only what I do on a day in and day out basis, but also what I get to do outside of work. So I want to talk a little bit about the backstory here. And the backstory on this one really was Maureen came to me and said, hey, let's do a webinar and kind of tie it in. And we started looking at the webinars and thinking about it. And this was something I'd never really done before. And the thankful part, it really comes from the fact that over the years, I've done hundreds of assessments in different facilities, in different verticals, industries, different environments, different places in the world. And at the end of the day, there's always these things that when I see that they have them in place, I'm like, oh, that's a good thing for them. That's going to help them improve the reliability in that facility. That's going to help them go after asset management. That is going to be one of the enablers. And so that's where I'm coming from with this presentation today. I'm going to talk about some of the things that when I'm doing an assessment and I see them, I immediately think, wow, that's going to make a difference for these guys as they move forward. So with that said, what I would like to do next is I would like to have you participate a little bit. And I want you to think about your facility. Think about what you've got going good for you. Do you have certain people like planners or reliability engineers in place? Do you have a really supportive leadership team? Do you have just any one of a number of things? What are you thankful for? Take just a minute, go down to the comments field there and or the questions field. And put a couple things in there that you're thankful that you have at your site and you believe it's going to help you get the reliability that you're going after. I'm going to give you guys about a minute to do that, and then once Maureen gets a few of them, she's going to read them off to us.
Don't be shy.
All right, I'll give you guys just a second more, but go ahead and submit a couple things. Hopefully you got something you're thankful for in your facility. There's got to be something. So if you can, put those out there, and we're going to talk about those more as we move forward.
All right, we've got some answers coming in. Shall we start letting me know what they are?
That sounds good.
All right, so I'm seeing they are thankful for a very competent mechanic/electrician crew. That's nice.
Good one. Yeah.
Grateful. Here's a good one. Grateful for management that trusts our decision making, even if they haven't fully understood it. Grateful
that's a really
for good planners. And I promise I didn't pay someone to say this. Grateful for ultrasonic equipment. Grateful for good reliability engineer. Grateful for a CMMS system that keeps better info. Grateful for a lubrication engineer who's been able to standardize on lubricant for them. Grateful for a client that wants to make a difference in their maintenance world. And let's see. Another grateful for planners, good managers, reliability engineer, and that we have competent technicians and controls team and the use of predictive tools. So some great answers there
great.
from folks.
Yeah, those are great.
And
they
feel
really
free to
are.
keep them coming in too. Yep.
Yeah, keep them coming. We'll visit a few more of them as we go a little further. But those are some great answers, and you guys covered a lot of what I'm going to be talking about today as we go forward. So good to hear that. I think it's absolutely critical. Sometimes we get in a situation where we kind of only see the negative. We only see the dark. We only see the black side of the facility. And sometimes you just need to step back and say, okay, but what do we have that's working? What do we have that is doing well? And to be honest, you may need to advertise and sell that a little bit. So are you telling others in your organization the things that are really working well, and thanking them for being a part of it? So let's dive a little deeper. So the first thing, and you guys said it, at least two of you mentioned the planner or the planner scheduler. And I threw up Charlie Brown here, and I think you see Charlie Brown's kind of leading the way. And the planners are one of those areas where you really do benefit tremendously by having that role identified and having them executing the right kinds of things. I'm going to dive deeper into that in just a second, but I think the big thing for me really is that when I go into a facility, if I see that they have a planner scheduler, I know that they've just cut down their implementation time significantly. And if I think back to a couple of facilities, and one in particular, a rolling mill from years ago that I worked with, they knew they needed planners. They wanted planners. They knew it needed to be a part of their master plan. But the unfortunate thing was they had to find these folks in the industry that could come into these roles. And, sometimes taking your best maintenance technician and turning them into a planner is not the right answer. So it took them quite some time in the job market that they were working in, which is really not that different than today, to find folks to staff those roles. So when I go in and I see that they've got those planner schedulers, it definitely is a big aha and a kind of a woo, if you will. It's okay, that's going to be there to support us. Now, just to be honest, as many times as I find that they have planners, I also find that they have people called planners. And if you've ever seen some of our funny videos, there's a lot of people out there that call themselves planners, and when you start looking, they're really not planners at all. I've seen, planners as parts gophers. I've seen planners as fill-in supervisors. I've seen planners in contract management roles. So, you got to be careful about, what a planner scheduler truly is. And, if you're interested in some of our kind of funny planner scheduler videos, hit me up at the end of the presentation and I'll send you a couple that kind of highlight what we believe a good planner scheduler is and what they need to be doing. Now, the second thing you see here in this slide, and I had to put it at the bottom, is the planner and scheduler. They can be really great, but if they don't have a process for moving things through the system, and this is more than just the CMMS, this is the business process that they're going to use to get information flowing back and forth, that good planner can really be hampered moving forward. And let me show you why. This is something I call the web of reliability, not to be confused with any of those other reliability webs out there. But if you take a look, what we've got here is a look at all the different interactions that are going on in a typical maintenance and reliability organization. And I really haven't finished this graphic. I could add quite a few more arrows in as I look. Every time I look at it, I kind of think of a few more things. But my point for showing this, the planner is a very key step in these processes, but they also pass information back and forth to different parts of the organization. And while this looks very convoluted and tough to figure out, that's really the intent, is people need to understand that there is a lot of stuff passing back and forth through the planners and some of the other positions we're going to talk about as we go through the rest of this webinar. So if you haven't figured out what goes into each step and what comes out of each step, if you don't know what that process is and how you're going to do it within your facility, you can have a really good planner, but you've tied at least one of their arms behind their back. All right, let's take another look here at the some of the other things that are a part of the planning process, and this is what we call our funnel model, and it's really a way for looking at work management. And to be honest, we could probably spend the whole webinar just on this model, so I'm not going to spend that inordinate amount of detail and dive down into the model itself. But what I do want to point out is, at the end of the day, the planner really, if they're doing the right kinds of things, they need to be managing total backlog and creating ready backlog. And so what I'm talking about here is making sure that work is getting identified, that there's an approval process, that it's getting into this funnel, that we're managing the amount that's in the funnel, not allowing the funnel to overflow as time goes on, and then creating job plan libraries and getting ready backlog so that when you go to do that job in the facility, you've got the tools, you've got the parts, you've got the procedures, you've got the permits, you've got everything you need to be successful in doing that job. Now, what I see, and I said earlier, sometimes I see planners doing things that I really wish they weren't. What I see in a lot of facilities here is they focus very heavily on that straw in the middle. And that straw for us represents the PMs and PDMs that are coming through. And I'll go into a facility and maybe all the planner does is print out PMs and PDMs and shuffle them around in the facility. That's not what we're talking about when we talk about a good planner scheduler role. So hopefully you can be thankful for what you have from a planner standpoint. And hopefully you're able to take that next step and create those good ready jobs that the scheduler can then put onto the progressive schedule. And I show that over in the blue box on the right-hand side. You can kind of see where we're scheduling work further and further, all the way out to the 4th week. We're scheduling that work because the planner is maintaining a good handle on the total and ready backlog. So don't want to make this all about planners and schedulers, but when I go into a facility and I see a planner that's doing it well, it's definitely a comforting thing that I know that that's going to really shorten their implementation time and help them with a lot of the improvements that they're trying to make. Now, I've got two positions in here that there are not a given. Every facility I go into doesn't necessarily have all of these disciplines, but these are the two, planner and scheduler, and then reliability engineer and maintenance engineer. And, I heard you guys mention that you had good reliability engineers and you were thankful for that. I am too. I go into a lot of facilities where this role doesn't exist. They have a maintenance supervisor or a maintenance manager that is expected to do both roles. They're expected to do things like root cause analysis. They're expected to PM optimize. They're expected to also manage their people, manage the training, manage all of those things. And it's just really more than the role can handle in a lot of cases. So having a good reliability or maintenance engineer, and I'm going to talk about the difference in the two here in just a second, but having those folks on board can be absolutely critical and just a huge benefit for the implementation. I actually just sat on another webinar that happened from, I believe, 11 o'clock till 12 o'clock. SMRP was putting it on. And the individual on that call was functioning as a reliability engineer in a facility. And he was telling the story of their journey. And really the things I'm going to show you here in the next few minutes are some of the things that individual was doing within that facility. You'll notice I had a little fun with the labels. The reliability engineer is there as a penguin, as a pilgrim, and the maintenance engineers there as a turkey. But you'll notice there are two maintenance engineers in this facility, so we got a turkey and an Indian. I did this to really kind of make a point. If the maturity of your facility is very low from a reliability standpoint, you're probably going to need a few more maintenance engineers or folks kind of functioning in that maintenance engineering role. Whereas as you mature, as your processes and systems get better, you're going to transition more to where those individuals are focusing more on reliability engineering discipline. And the best way to separate it, although it's not a perfect way of thinking about it, the best way I've found is that reliability engineers are more purely focused on mean time between failure, whereas a maintenance engineer is more focused on mean time to repair. And again, that's not a perfect comparison, but I think it helps folks understand. Maintenance engineers get down in the day-to-day. They help folks write better maintenance procedures, try to identify and eliminate stuff that we're inducing into the system from a failure standpoint. Whereas your reliability engineer is analyzing more data, is focused more on the long-term picture, is really trying to take you to the next level. And you don't ever just want to have one or the other. It really needs to be a blend. But my experience tells me that it needs to be a blend based on the maturity of the organization. Now, what do they do? In case you don't have them in your facility, I threw a few slides in here. I'm not going to go into the nth degree of detail here, but I do want to talk a little bit about what I would expect from a maintenance and reliability engineering discipline within a facility. And I say discipline because I don't think they have to be degreed engineers. I think that's a mistake that a lot of folks make. So if I go into a facility and I find a technician that's been promoted up maybe into what they call a reliability technician role or something like that, and I see that they understand the kind of things that I'm going to talk about here in the next couple slides, I'm still thankful. That's absolutely what I'm looking for. It does not have to be a degreed engineer. So with that said, these are the failure curves, the 6 failure curves from the original Nolan and Heap study. I and a couple other folks within my organization are spending a lot of time right now digging into the data on these. We believe there's a bit of misinterpretation of what these mean, but what I will say to you is that there is a big piece here right down there at the bottom that says non-age related failures are 89%. And if non-age-related failures truly are that high, then your use of some of the other things that we're going to talk about a little later, like predictive maintenance and condition-based maintenance, becomes absolutely critical. Because at that point, it's not a time-based PM situation. It's not something where you can just say, okay, every 6 months I'm going to replace that part because it's going to start failing at 7 months. In reality, we know that there are operators and maintainers both running around the facility introducing defects. Those are not time-based. They're very random in nature. And it's one of the reasons, to be honest, that I think a lot of organizations are struggling with their implementations of Industry 4.0, the Industrial Internet of Things and IoT. I think everyone's trying to analyze data, and it's just not getting them where they want to be. I think we'll see over time that more people will realize this random nature is something you can't detect with machine learning in all cases. Not to say the technology is not great, or not to say the technology won't be a good thing in the future, but right now I think some pretty bad assumptions are being made, and I see quite a few of them being pushed out on the internet. So some of the other things that you will see from a reliability engineer or a maintenance engineer, they start to understand something we call the I to P to F, or the P to F curve. And this curve here, we're talking about how assets fail and what their probability of failure is. And as it goes down the curve, the probability of failure is going up. But what it also tells us is using things like ultrasound and vibration allow us to detect these problems much earlier on the P to F curve. And that gives us time to then go back to our planners and schedulers from the first one and say, hey, let's plan and schedule this repair and make sure we do it at the lowest cost with the highest value and the highest safety that we can bring forward. So this curve, it becomes a thing that I think a lot of maintenance engineers and reliability engineers are really playing over in their heads and trying to understand, is our maintenance strategy all way down there close to F, where the equipment fails within days of us detecting it, or are we detecting things early enough to be able to truly plan and schedule those repairs, reducing the total cost? Now, the next area that especially maintenance engineers are going to focus on, but I'll tell you, reliability engineers spend a fair amount of time in here as well, is something called equipment maintenance plans. And over the years in doing assessments, this is one of the things we always look at. And in looking at them, a lot of times the equipment maintenance plan is just a combination of steps and PMs that were provided by the original equipment vendor, or it's a combination of things that have been added in the middle of the night because something's failed and somebody wanted to be able to say in the morning meeting that they had done something about it. There's just a lot of junk in equipment maintenance plans. So when you start breaking them down into the individual task level, which is what we do with our equipment maintenance plans, and you start looking at the failure modes and you start looking at the tasks, you start to realize that many of those failure modes, they have no coverage. There's nothing to detect them in the current plan that we have. On the flip side, you also start to notice that there are things in there that people are recommending we do that have no real effect on a failure mode. So it's just a completely non-value added activity. So with that said, as you go through and you start to scrub and analyze your PMs and optimize them and add in some of the other things, condition-based maintenance and others into those equipment maintenance plans, you really start to in many cases scrub out a lot of non-value added activity, but more so than that, you start to truly address failure modes and it becomes a failure mode based maintenance strategy. Now, I thought I would show an example of how this could happen. You know, a lot of PMs that I'll pull out during an assessment, it'll say something like inspect the hydraulic hoses or inspect the hydraulic hoses for wear. And I love this example. There's a couple of them in the presentation, but when you start looking, just by thinking about the failure modes, how is this hydraulic hose going to fail? How is it likely to manifest itself over time? We can start to create a much better PM or a much better PM task. So you see here, instead of just saying inspect the pump, inspect the motor, inspect the gearbox, now we're saying inspect the hydraulic hose. But I don't want you just to inspect it. I want you to tell me, does it have no wear? Does it have mild wear, like scuffing on the outer casing? Does it have moderate wear where we can actually start seeing that braiding being exposed? Or does it have severe wear and have frayed braiding that's already started to wear through? So this becomes a task that is truly failure mode based, and it tells that technician exactly what they should be looking for when they do it. If you do this or the next one, which I'm going to show you, these can be done by lots of different technicians in your organization, and you'll still end up, no matter who does it, with a very similar result or a very repeatable PM process. So these are two examples here. There are two examples where we wouldn't traditionally use predictive maintenance. So we need the PM, but we need the PM to be addressed directly to a failure mode and give us a real example of what we ought to be looking for. How bad is it? Now, as we transfer kind of over to the reliability engineering side, and we've just kind of transferred all the way through as we looked at these, here is where, you know, a lot of REs will spend their time, and that's tracking defects or tracking overall equipment effectiveness, trying to understand not just where are we getting the defects there in the operate and maintain area, but where are we getting those defects in the design, buy, store, and install phase. Are we designing equipment for the application that we're truly going to use it in? We work quite a bit in automotive, and one of the issues that I see there regularly is, you know, equipment was designed to last 7 years, the period of time that an average car model runs, and now they're asking it to run 14 years or 21 years. That thinking is changing. So it's not designed to last the life cycle that they are now wanting to do, and that is leading to some of those issues. How we buy it? Do we buy the cheapest thing out there, or do we buy something that takes into account something we call life cycle cost? In other words, do we buy something that has the cheapest purchase price, or do we buy something that will have the cheapest total cost of ownership over its life cycle? So the reliability engineer is focusing in all these different areas, everything from storage, install, operate, and maintain. And this is an adaptation from a gentleman by the name of Ron Moore, a mentor of mine, who has really taught me a lot over the years. And in looking at this, he always likes to point out that there are three areas here that have higher defects than the others. And you can kind of think of that as negative OEE. Design, install, and operate are all areas where if you don't have good procedures, if you don't have good processes, if you don't have good standards, then you're going to introduce those defects at a higher level, and then you have to deal with them for the rest of their life cycle. Now, here's one that I think is absolutely critical, and when I see a facility that has this, I am always thrilled. When I go into a facility that doesn't have it, I always let out a little sigh. Because over the years, I've worked with a lot of reliability implementations in a lot of different facilities, and if they don't have a good burning platform, it is really, really hard for them to be successful. And what I mean by that is, and I'll give you an example. I went in years ago into a pharmaceutical facility, and in that pharmaceutical facility, their reason for doing the maintenance improvement effort was because one of the big five consultancies told them they should. That's not a burning platform. And because of that, they really struggled putting the effort into it to be successful. Now, I'd say they made great progress and they did good things. But they didn't get to the level of performance that they could have if they had been able to really drive the organization forward. Now, the flip side of that, and those of you that have heard me talk about change management, know I talk about a paper mill up in Canada that I worked with about, I'll say, 8 or 10 years ago. And in that paper mill, when I arrived, they told me that they were closing 2 mills every year. They were doing it off of their conversion cost, or what it cost them to convert raw product into final product. And these guys were let's just say they were second to last. So if you're closing 2 mills every year and you're second to last, it's not looking too good from that perspective. Now I go on to find out that the facility also has 5 unions within that organization, all with slightly different opinions about how the plant should be run. But as we got to talking with both the unions and the leadership, we started to understand they had a real burning platform. For the union, they knew they would lose their membership in less than a year if they didn't do something differently. And for the plant, they knew they would lose the whole entire facility if they couldn't come up with a better way to convert paper in that facility. And they did just an absolutely incredible job of doing a lot of the right things. And because of that, they were able to move from second to last all the way up to second from the top. They settled out about 2 or 3 stops down on the list, which is pretty normal. But the point is, when I walk into a facility today, and I had this just happen to me with a facility just recently over on the West Coast, and I looked at, what they were doing and the passion that they had for it and the burning platform that they had, and I was thankful. I knew that they stand a really good chance of being successful. I look at, an automotive facility that we've worked with for about 3.5 years in Alabama, and there was a passion and there was a burning platform. There was a reason that they had to change. Same goes for a pharmaceutical plant up in North Carolina. They know that they need to change, because if they don't, it's going to be a different world. And that, if you have that within your facility, as much as that can be painful, to be honest, it is a huge benefit to getting these things done and getting them in place. So here's the bad news. Everybody wants change, but nobody wants to change. And that's the struggle that you're going to face. And there's, while implementing reliability has lots of details, and there's lots of things that can be done right or wrong, and certain orders that things need to happen, there's a lot of technical detail. At the end of the day, the hardest part of any reliability implementation, asset management, or maintenance improvement is going to be getting people to change, getting them to do it the new way, getting them to put data into the CMMS, getting them to do root cause analysis, not just blaming the people around them. All of those things are going to be hard to change. So if you're thinking about reliability improvement and you're not thinking about the people change, my suggestion to you is you're in for a long road. I would dive into things like the Cotter model, things like ProSize ADCAR model, situational leadership by Ken Blanchard. I think is another really good tool that you can use to kind of help with changing the organization. But if you have questions about it, hit me up at the end of the presentation, and I'll share more of the details with you on that. Some of the things that I see within a lot of facilities is they get a lot of things right, but they leave one little crucial detail out. And I love this slide. It's been around for years, but I love looking at it and kind of seeing some facilities that I've worked with in the past. If you don't have a good vision and strategy for where you're going, and that a little bit equates to that burning platform I just talked about a minute ago, you're going to have confusion. If you don't have good knowledge, skills, and abilities, which I know when we were talking earlier, one of the guys shared with us that he was happy to have a good set of craftsmen or technicians in his facility that have the knowledge and skills. But if you don't have that in your organization, then you're probably going to live in anxiety. If you're missing positive or negative incentives, I refer to it a lot of times as the carrot and the stick. You can make change, but it's going to be a lot slower than it could be or should be. If you don't give the resources to get things done, you're going to see a lot of frustration within the organization. And then, if you don't have a good, they call it an action plan in the graphic, I call it a master plan and talk about it quite a bit. You guys probably that know me get tired of hearing about it. But that action plan is absolutely critical because it leads to preventing false starts and people going in different directions or going in the wrong place at the wrong time. So managing complex change is a big issue. You need to make sure that you've got all of these boxes checked as you go through that, and be aware with where you want to go and why you're going there. Now, another part of the change management process that I think is very important is the implementation model. How are you going to get it out to the organization? And we created this graphic about a year ago, and I'm pretty happy with it because I think it really helps people to understand a problem that we see a lot of times. Many organizations just want to do everything everywhere all the time. And if you refer back to that slide we just looked at, you just don't have enough resources for that. So because you don't have enough resources, you end up failing, or you end up having results that are taking longer than you expected them to. So one of the methodologies we use, and we have a product called IBL. It's a blended learning process for training reliability engineers, maintenance managers, that sort of thing. But those are the yellow dots that you see in there. And what we do is we use them as little internal consultants. They understand the big picture. They understand why we're doing reliability. They understand where we're going with asset management. They understand all of those. But then they're surrounded by a little team of individuals from out in all the areas of the plant that they work with on a specific task. And that might be work control and planning and scheduling like shown here, or it could be operator care or criticality. But there's a small group working with that IBL in a pilot area, which I think is absolutely critical. But in a pilot area, they're focusing on making sure that the changes that they want to make are going to work for the rest of the facility. And we picked that pilot area very deliberately. We want somewhere that's highly visible. We want somewhere that the organization can see and will get a good benefit from. But we also want to be successful, because if we're not successful in the pilot area, we'll never see the rest of the plant. And then once we are comfortable with that pilot area, that we got it implemented in that area and it's working the way it's supposed to, then we begin to roll out to the other areas of the facility. Now, over the years, I have had, I don't know how many facilities that want to do everything everywhere immediately. And it's not, I won't tell you that it doesn't work. What I will tell you is it takes them tremendously longer than it would if they had focused on that pilot area, got that success under their belt, because that success in the pilot area creates a pull in the rest of the organization instead of you having to push everything moving forward. Now, the next thing that makes me happy, makes me excited to see, is operator involvement. And I chose Huey, Dewey, and Louie here to kind of show us what it looks like in a lot of facilities. And you know, it very well could be a fight over resources. It could be a fight over time, fight over the equipment. But at the end of the day, you got maintenance on one hand, you got operations on another, you got engineering on another, you got safety, health, and environmental, and everybody's pulling on the turkey. So if you can get operators involved in your reliability improvement strategy, what I think you'll see is that that's going to make it so much easier to move this thing forward. Now, I am going to caveat this one because I don't think you necessarily need to get operators involved right out of the gate. I think there's a time and place. I think you need to get your house in order first. I think that, you know, if you're not planning and scheduling work, if you don't have a good way to get work requests through the system in a timely manner, then operator care is just going to mess everything up because they're generating a lot of requests and you're not doing anything about it. And then they quit generating requests and go back to doing things the way they used to. So operator involvement is something we definitely want. We want them involved from the beginning, but we want to get them really involved after we get some of that foundation in place. Now, one of the issues with operations and maintenance is they see the picture differently. And if you take a look at this picture, I'm going to give you about 15 seconds here to look at the graphic and kind of think about what you see. So some of you, I would imagine, you see 6 animals on this picture. Others of you, however, see 3 twice. And I think that's one of the things that we have to keep in mind, and it goes for really all of us. At the end of the day, we have a very good understanding of the way we see things, but do we have a good understanding of the way the rest of the organization sees it? And what I mean by that is I hear a lot of times maintenance folks will come to me and they'll say, well, you know, operations will never give me the equipment. And I get that. And I know that that's a problem. And I know that doesn't allow you to get your PMs done. And I know that that doesn't allow you to do corrective maintenance work. But I have to turn around and kind of look at it from operations side. The last time they gave you the equipment, you didn't give it back to them on time. Or the last time they gave you the equipment, when they started it up, it didn't run. So, yeah, I kind of see why they may not be interested in giving you equipment, because every time they give you the equipment, they suffer the downtime coming out of it. And I use that example, but I like for folks to kind of look at, you know, as you're going through reliability improvement or asset management, excellence, or whatever your focus is in your organization, make sure you understand how others, some would say customers, others would say partners, but your partners in crime in the organization, how they see it. And it probably wouldn't hurt to ask them. One of the exercises that we like to do is getting both groups together and basically completing a contract or a partnership agreement to say, hey, here's what I expect from operations. And operations looks back at maintenance and says, well, here's what I expect from you. You may ask that the operators not go on break every time the equipment breaks down, so that there's someone there that can tell them what happened. But they may turn around and ask that you give them back the equipment in a timely manner. But that dialogue and discussion can be really important to helping you see both sides of this picture. Now, this is another graphic, a little hard for you guys to read, but it's a graphic that's been around for a little while. I created it for a magazine article a few years back, and my point for putting it up here today is that a lot of times it's not about finding root cause. It's about pushing the blame on somebody else. And if you're battling that scenario in your organization, then you've got some work to do from the very beginning. And I'll show you what I mean a little later, but you've got to dig deeper down into these problems and understand, okay, what, not who's at fault, but what in the system allowed them to make that error. Whether it's a process or the lack of procedures or the lack of training, there are other things down at the systemic level that are causing these problems. It is not just about passing blame or making sure that we move it off of the maintenance log and over to the operations log. And here's what I mean by that. If you look at this graphic here, this is where do GTEX come from. It's an older graphic. I think it's probably about 15 years old when it was originally done through the study. But what is interesting is, defects, as we looked at them in the OEE slide earlier, Ron Moore's slide, defects come from all over the organization. They don't just come from the way we maintain. They don't just come from the way operations runs the equipment. It's also about how we store those items in the storeroom and how we purchase them and how they were engineered originally. And the sales and marketing side of, are we selling the right product that we can really make on the equipment that we have? So all those things kind of come into play. And you notice I left the big red one out because nobody wants to blame management. But, management makes decisions. They make choices. And sometimes they're the right decision. I think back to years ago, I was working in a chemical plant, and the leaders of that organization wanted to quit doing repair on the roofs. It was going to save them a couple $100,000 a year to do that. Now, obviously there's a cost to that. That roof that was supposed to last 7 more years is probably now only going to last 3 more years. But what management knew that we didn't at the time was, if we didn't cut our costs, we weren't going to be there in 3 years anyway. So when we put management up here, it's not to throw management under the bus. They're making decisions based on the data that they have. It's our job as reliability professionals to communicate the risk associated with that to them so that they can make the best decision. But when you don't always get what you want, what you have to realize is you may not have the whole story. Now, not only does it come from different parts of the organization, and I've shown this through Ron Moore's slide as well as some others, but the cost that you're expending during the maintenance and operations side of the process, a lot of that was dictated very early on. So if you're not getting engaged with operations together early on when they're speccing out the equipment, there's a pretty good chance that while you may be getting equipment that can do the job, or maybe not, but you're getting equipment that should be able to do the job, you may be getting, different PLCs that you've never used or different motors that you've never used. And now you've got to carry additional stores in the storeroom. So there's a lot of things that I think maintenance and reliability folks know. We just need to find a good way of communicating that early in this design phase so that we can do our best to keep the total cost of ownership at the lowest point possible. A couple more things I'm thankful for, and then we'll kind of wrap up here. The next one is definitely PDM and CBM, predictive maintenance and condition-based maintenance. I think it's a very powerful tool. You can see that Marvin the Martian here has his UE 10,000. You can tell it's a 10,000 because there is no screen. So he's got his UE 10,000 here. He's ready to go. And I think the PEM and CBM technologies really, they empower us to be able to do other things in the organization. An example of that would be that we're able to, identify something early so that we can plan and schedule that repair. That planned and scheduled repair is going to be safer. It's going to be done at a lower cost. It's going to be done with less infant mortality induced failures. It's just got so many benefits that all come from the PDM and CBM standpoint. So if I go into a facility and I see that they have good PDM technologies, they've got ultrasound equipment, they've got vibration equipment, infrared, those sort of things, I'm excited already. Now, the second thing that makes me even more excited is if I walk over to those cases and there's not 2.5 inches of dust built up on top of them. Unfortunately, that happens in a lot of facilities because they'll put these technologies in play, but they don't have the processes to support them, so they don't get the results that they expected, so they quit doing it and put them on the shelf. And so at the end of the day, get your processes in place. That's going to help you use these tools very effectively. But I am thankful to see a group that has already trained and bought into CBM and PDM. Just like I talked with the planner scheduler, they're hard to find. It takes a while to get them. The reliability engineer is the same way. CBM and PDM technicians are also the same way. You've got to train them. You've got to get them up to speed, and that takes time. So if I go into a facility and I see that those folks already exist in the organization, I'm thankful for them that they're going to be able to do that. Now, the next thing I'm going to talk about is not just having these technologies, but using them very effectively. And the example that I brought today is a vibration example. And what we're looking at here is a bearing failure. It's a bearing defect. It's starting to progress. And a lot of times we'll use vibration to identify these, and the technician will then put in a work order that says replace the bearing. Well, that's great. But at the end of the day, if the individual just puts in a work order to replace the bearing, what we're going to find out is the bearing's just going to fail again. The bearing is going to travel down that same P to F curve, just like the last one did. So yes, we're going to get the opportunity to catch it on another vibration route, and we'll get another catch. But at the end of the day, if we had used the predictive technologies to empower our processes, then we would have been able to detect it and then identify what caused it, and then prevent that from happening down at the systemic and latent root level so that it doesn't repeat over and over and over. So if you've got the predictive technologies, and that's great, that's wonderful. But if you're not using the predictive technologies to empower your problem solving and root cause analysis, then I think you're missing a piece there. And that'll give you a little something more to go after as you move forward. Now, in this example, I like to show the fact that the reason this bearing failed was because somebody chose to install it with a hammer. All right, and we see this a lot in facilities. It's something I refer to as percussion maintenance. Instead of using precision maintenance, instead of using a bearing heater and heating this bearing up and sliding it onto the fitted shaft, instead we just grab a hammer and knock it on. Works great at home in the garage. Why would it be any different in the plant? And then we end up with the defects that you can see on your screen. So this is a perfect example, though, of where using the predictive technologies, I can catch this bearing failure very early. Because I called it earlier, I can cut open this bearing and take a look at it before it's destroyed, and I can see what occurred. The evidence will be here that will help me with my problem solving. If I'm just running it to failure, by the time it runs to failure, all of this evidence will be destroyed. It'll be spalled out internally, or it'll be a puddle of metal on the floor. So we can't use it to understand what really caused the problem to happen. So your PDM tools, of course, make your planning and scheduling process more effective, but they also empower your problem-solving process to make sure that you don't have repetitive failures. And that's a big reason why I'm thankful for those PDM tools. Now, this is a graphic that kind of shows what I'm talking about here, and I'm going to go through this relatively quickly because we are close on time. But what we see here is you've got a failure up there at the top. That's our bearing failure. Down at the physical level, or maybe that's the motor that is the failure at the very top, and down at the physical level is that bearing that's failed. And then we get down to the human root, and we see that someone installed it with a hammer. And then we move on down to the systemic root, and we start to understand, well, the reason they did that is no one's ever told them that precision maintenance is really that important. So then if you get down all the way to the latent roots down there at the bottom, you start to realize that the reason is because no one in the facility really takes the time to talk about precision maintenance. It's just not a cultural value for the facility. So that's a simple example of a root cause, but we're drilling down into that problem using the data from the technologies to better understand our issues and what caused them so that they don't happen again. Now, I brought a few more technologies here with me. I'm going to kind of move through these quickly, but the main point I want to make here is that there is not just one technology. You can't survive just off of ultrasound. You can't survive just off of vibration. You need to have a set of tools. And so I'm really thankful if I see that they've got vibration, ultrasound, infrared as part of their program, because I know there's going to be a better chance that they're going to be able to detect more of the common failure modes moving forward. Now, in this example, you see this is mechanical. It's belt tension being too high, causing the bearings to heat up. The next one is a traditional electrical issue. We've got a loose connection. And the next one you see here is a kiln that is starting to lose its insulation. And so there's three really quick IR examples that are completely different. We're using one for mechanical, we're using one for an electrical issue, and we're using one for what I'll almost classify as structural, although you could probably argue that it's mechanical. But there are different ways of using these tools. Don't be afraid to branch out. And I've pulled up now a little bit of ultrasound. And when you look at ultrasound, of course, we know it's great for leak detection. We also now know that we can use it from a lubrication standpoint, but we can also use it for our electrical inspections to identify things like tracking and arcing and corona. And I'll play this sound real quick so you guys can hear it. So using the ultrasonic technologies, using the infrared technologies, using them all together gives us a much more effective understanding of what's happening, again, giving us the time to then plan and schedule the repair, but also the data to be able to problem solve that issue moving forward. So let's recap. We've got just about 5 minutes left here. So the big things that we've talked about today and the things that you guys said you were thankful with from the very beginning, planner scheduler, having that in place is absolutely key. Having one that is actually functioning as a planner and or a scheduler is even more important. Having reliability engineers and maintenance engineers, again, they don't have to be degreed engineers, but having someone who is really working with your planner and working even long-term with the reliability engineer to find solutions for problems so that they're not repeating. Creating a desire to improve or a burning platform. If you don't know what your burning platform is today, let's sit down and talk. I mean, take a few minutes, send me an email. Let's set up some time to talk, because if you're trying to implement reliability improvement and you don't have a good burning platform, you're going to struggle. So I'd be more than happy to help you kind of identify what that might be. Operator involvement, again, it's a wonderful thing to see operator involvement, to see them understanding that, if we work together, reliability is good for everybody. And at the end of the day, you can have way too much maintenance in your reliability efforts if you don't have operations engaged. The last one that we talked about was the PDM and CBM technologies. Man, I love going into facilities that already have a PDM and CBM process in place in a program, because I know that they're getting those things identified early, as we just talked about in the long term. So let's hear from Maureen. Were there any other things that people were thankful for before we move on?
Just another CMMS came through. That seems to be a big one. Someone else is thankful that they have a great mentor teaching them PDM technologies and precision alignment. But I think I like that mentor one. One of the things not sure was really covered was kind of that idea of, having that leadership. I mean, obviously you touched on leadership, but who's really the one, the cheerleader, who's going to help everybody kind of come along and get everybody fired up about this stuff. So having people like that in place seems like something to be for sure thankful for.
Oh man, yeah, those are both of those are really great things to be thankful for. Having a good CMMS and having a good process to drive that CMMS is absolutely critical. You can do it. You and I were talking earlier, Maureen. I've seen facilities that didn't have a CMMS, but man, it's a lot harder to run a maintenance organization when you don't have the benefit of the computer to drive that forward. And then, your last comment about having a mentor, couldn't agree with you more. That's why our IBLs always have a mentor as they go through our program. Because at the end of the day, you get stuck and you need somebody to call and you need somebody to ask, and you really need to get an answer fairly quickly, not wait till the next meeting or the next conference. The sooner you can get an answer, the sooner you can try it and move on and improve your organization. Any questions from anyone that we've received? I know we don't have a lot of time.
Yeah, we had a couple that are pretty ultrasound specific, and while I'd love to put you on the spot and test your knowledge of all things ultrasound, I think it's best if we handle those and reach out to those folks. individually. But yeah, it's we're certainly at UE Systems thankful that we have people like you, Shon, that we know ultrasound, but when it comes to all these bigger picture reliability things, we can barely scratch the surface. But that's why we've got friends like you that can come in and help our customers and webinar attendees out and share all this great information. So thank you very much for that. And so it looks like, so Shon's got his info up there on the screen. So make note of that if you guys want to get in touch with him. Like he said, if you want some help kind of figuring out what it is that your burning platform is and how you need to get started, so that if you don't have all these things, we can get you down the path towards getting them, so that by, maybe next Thanksgiving you'll have all those things in place. Might be a little aggressive, but got to have goals, right? So like I said at the beginning, we did record this. We'll be sure we get this up on our website. If you want to email me to get the link for it, feel free to do that. And then if any other questions come through, Shon, I'll be sure to get those to you. You can follow up with folks one-on-one, but I do want to, in the interest of everybody's time, let everybody go at the 2 o'clock hour here. All right?
Well, thank you, Maureen. Thanks for having us. We enjoy doing these with you guys, and wish everybody a happy Thanksgiving.
Awesome. Thank you. All right, everybody. We'll hopefully see you back here next month. We'll finish out the year with another great webinar, and we'll get that info out to you guys just as soon as we can. Thanks.